Alright, in our next lesson on matrices, we're going to be doing determinants and inverses. So we've added and subtracted, and we've multiplied by both a scalar, and we've multiplied two matrices together. So now we're going to be finding determinants and inverses, which is, again, something new. Well, basically everything in this chapter is going to be new, because you probably haven't seen matrices before. Okay, so our question is, why is it important to understand the inverse of a matrix? We're going to be determining whether matrices are inverses, and then finding the inverse of a matrix. Okay, so first, before we start, we're going to talk about identity and multiplicative inverse matrices. So for a matrix that's n by n, that means it's like 2 by 2 or 3 by 3. So these are square matrices. The multiplicative identity matrix is an n by n, so same size matrix, with 1s along the main diagonal and 0s other places. So here's an example. So this would be a multiplicative identity matrix. So along the main diagonal, that A1, 1, and then B1, 2. Is that how it works? Yes. Those are going to be where our 1s are, and everywhere else is going to be 0s. Okay, if we had a 3 by 3, it's along that same diagonal, and everywhere else is 0s. If A and B are square matrices, and A times B equals B times A, and they both equal 1, then B is the multiplicative inverse matrix of A, which you can write as A to the negative 1 power, which we've talked about those before. Multiplicative inverses just means inverse. A to the negative 1, B just means that specifically it's a multiplicative inverse. Okay, so determining whether matrices are inverses. Are matrices A and B inverses? So we need to find if A times B equals 1, we need to find if B times A equals 1. Okay, so here are matrices A and B. To find out if they are inverses, we need to multiply them together. So let's take A times B, and then we also need to take B times A. So let's go ahead and do A times B. So AB is equal to 1 times negative 2 is negative 2, plus 2 times 3 halves is 3, and this one, that's 1 minus 2, and then in the bottom we have negative 6 plus, let's see, that's 2 times 3 is 6, and this one, that's 3, and 4, negative 2. Okay, so let's go ahead and simplify these. So AB is 1, negative 1, 0, negative 1. Uh-oh, I think I did something wrong, because I think that first one's a 0. So that's 1 minus 1. Yep, found it. That's 0. There we go. And that's a positive 1. I promise I really can math. Okay, so A times B is our multiplicative inverse, our I. So that's good. Okay, now we also have to do B times A. Let me pick another color. So BA. And erase this stuff. So for B times A, we take this one times this one. So I have negative 2 plus 3, and I have negative 4 plus 4, and then along the other side I have 3 halves plus hold on a second. Okay, and then that's negative 3 halves, and then this one here, that's 3 and negative 2. So BA is 1, 0, 0, 1, which is also the identity. So AB equals the identity, BA equals the identity. So since they both are the identity, they are multiplicative inverses. So you could say B is A inverse. Okay, so let's try these really quick. Let's see if these are multiplicative inverses. Okay, so we need to find AB. So we take this one times this one. 2 times 2 is 4. 4 times -1 is -4. 2 times 5 is 10. 4 times -3 is -12. Then we have to do the bottom and the side. There's 4 minus 2. And the bottom and the other side. That's 10 minus 6. Okay, so when we simplify this, we get 0, -2, 2, 4. I can already tell you this is not an identity, so these are not multiplicative inverses. Sometimes you'll get one of them that is, but the other one is not. Alright, determinants. Every square matrix with real number elements has a number associated with it called its determinant. So to find the determinant of a 2 by 2 matrix, you use A, B, C, D, and then you just draw lines from A to D, you multiply those, and then you subtract B to C along the other way. For a 3 by 3 matrix, it's a little more complicated. So what you do is you extend your first two columns, A1, A2, A3, B1, B2, B3, into another one, and then you add A1 times B2 times C3 plus B1 times C2 times A3 plus C1 times, well, that one's not very straight, times A2 times B3. And then you subtract going up the other way. A3, B2, C1, B3, C2, A1, and C3, A2, B1. So you multiply across and add, and then you multiply up, across, and subtract. Hint, hint, we're probably not going to do a lot of those on tests and quizzes. But the 2 by 2 matrix we most definitely will be doing. So evaluating the determinants of matrices. So what are the following determinants? So I have a determinant of this matrix. 3, -1, 2, 5. So in order to find the determinant, we take AD minus BC. AD minus BC. So we take 3 times 5, and that's 15. And then we subtract 1 times 2, or -1 times 2. So that's -2. So we add them together. So our determinant is 17. Pretty simple. Okay, what about this one? I know these look scary. It's okay. Go ahead and we'll start by extending them. So 1, 0, 3, and 0, 4, 5. And then we're going to take and draw lines. This one, 1 times 4 times 2 is 8, plus 0 times anything is 0. And then we have 2 times 0 times 5, which is 0. And then we're going to subtract in parentheses. So we're subtracting all of these. Well, let me get out my eraser. Oops, that's not an eraser. So we can see these numbers a little bit better. We're going to go up this way. Let's see, that's 12, -24, 5, -5, and that one is 0. Okay, so we add up our numbers, 8, and then we're going to subtract -29, so that means we're going to add them together. So our determinant for this 3 by 3 matrix is 37. See, it looks a little scary, but it's not so bad. Also, you can do these on your calculator. So go ahead, get out your graphing calculator. Alright, now don't make me stab myself in the foot because I'm showing this to you, because I still want you to use your brains and not be monkeys. Okay, so on your calculator you have this matrix button. If you click on a matrix, you can go over here and edit, and you can make any size matrix you want. So let's go ahead and just do one of the matrices we just did. let's do, here we go. Finding the determinant of a 2 by 2 matrix. So first put in your dimensions. So this is a 2 by 2. And when you go down here to edit them, it makes it automatically for you. So we're going to put in 3, -1. Oops. They don't like my -1. Ah. Okay. Well, I'm going to have to put in it this way. -1. There we go. 2 and 5. So on this one, we found that our determinant was 17. So let's go ahead and exit out of this. We'll go back to our matrix. For math, we want to find the determinant. So we put DET, determinant, as the first one. Of what matrix? Our matrix A. So do 1. And then hit enter, and it shows you, oh look, your determinant is 17. So this is a good way for you to check your work, but not to do your work. I want to see that you can think for yourself. No monkeys. Ooh, ooh, ah, ah. Okay. Okay. So here we go. So inverse of a 2 by 2 matrix. If you are given that a matrix, ABCD, or you're given this matrix is ABCD, if your determinant equals 0, then A is what's called a singular matrix. It has no inverse. So if you do AD minus BC and you get your determinant is 0, there is no inverse. But if you get another number, any other number other than 0, you can find your determinant, or you can find your inverse by doing 1 divided by your determinant, and then you switch the places of AD. So these two have changed places, and your BC becomes negative. So switch AD, change B and C to both negative, and then you put 1 over whatever your determinant is, and then you just switch the places and switch the signs. So it sounds really complicated, but it's not. Okay, so let's find the inverse of this matrix. First of all, does it have an inverse? So we need to find out what is our AD minus BC. So AD is -9 minus -6. So -9 plus 6 is -3. Does this have an inverse? Yes, because our determinant is anything other than 0. So to find what our determinant is, so the determinant, or your inverse, excuse me, we found the determinant. So let's just call this A. Our inverse is 1 divided by our determinant, -3, and then you take your matrix, you switch A and D places, so now we have 3 and -3, and then you change the signs of B and C. So this becomes +1, this becomes -6. So that is our inverse matrix. Now, in order to finish this, we have to, I believe, distribute this -1/3 through. Let me check really quick just to make sure I'm not speaking out of turn. Yes, we do. Okay, now we use our rules of multiplication, and we distribute the -1/3 through to everything. So our A inverse is -1/3 times 3 is -1. -1/3 times -6 is 2. -1/3 and +1. So that is our inverse matrix. So you find the determinant. As long as it's not 0, you put 1 over the determinant, you switch A and D, change the signs of B and C, and then distribute that scalar through. Okay, so here's your lesson check. I want you to see if these are inverses. Do they have an inverse? That means, is their determinant 0 or something else? And then find the determinants of those two. So these 6 problems are going to be what you're going to do with your partner first thing tomorrow. Alright, and there's your homework. We will have a quiz on Thursday because we don't have class on Wednesday. There will be a quiz. Make sure you study for it. It'll just be over addition, subtraction, multiplication, and then determinants and inverses. Alright, hope you have a good night.